The subject of the principal communication, the topic is the multiplexing, demultiplexing, and vestigial sideband. So, what is the multiplexing and what is the role of multiplexing in the communication field? So, multiplexing, it is the set of technique that allows the simultaneous transmission of multiple signals across single data link. And multiplexing is done using a device called multiplexer mux that combine n inputs line to generate one output lines or many to one. Multiplexer means many to ones or many signal converted into one signals. So at the receiving end of a device called demultiplexer, DMAX, is used that separate signal into its components signals or one input and several outputs, one into many. So in the demultiplexing, one signal converted into the many signal or more than one signal. So this name is the one to many or one input and several output in the demultiplexer system. In multiplexing, in this diagram, there is different and input lines. With the help of multiplexer, these different input lines convert into the a link or into a channels, and that channels again at the uh, destination point or at the demultiplexer uh, convert into again different and output lines. So multiplexer convert n input lines into one channel, and again demultiplexer convert one channels or one link into different input output lines. So this is the example of multiplexing in this diagram. So what is the advantage of multiplexing? More than one signal can be sent, medium, or a link. This is the a disadvantage of multiplexing. Next one is effective use of the bandwidth of medium. So in this multiplexing and technique, the effective use of the bandwidth of the medium. And there is difference between the multiplexing versus no multiplexing. So in this diagram A, show the no multiplexing technique, and diagram B show the multiplexing technique. In no multiplexing, there is different system connected to one by one to different uh, another systems. What in the multiplexing, the different system connected to the multiplexing, and this multiplexing connect different system inputs into one path or one channel with the help of multiplexing technique. So again, the demultiplexing convert one path or one channel into different output channel or output signals. So this is the difference between multiplexing versus no multiplexing technique. What is the type of multiplexing? So there are different types of multiplexing. Multiplexing classified into the different multiplexing. First one is the frequency division multiplexing, FDM, that is the analog multiplexing. Second one is the wavelength division multiplexing, WDM. This is also analog multiplexing technique. And third one is the time division multiplexing. So this is the digital multiplexing technique. Again, TDM or time division multiplexing classified or divided into two type of TDM multiplexing. First one is the synchronous TDM and second one is the asynchronous TDM. So there are different types of multiplexing in the form of analog as well as digital. In frequency division multiplexing or FDM, it is an analog technique. Signal of different frequencies are combined into a composite signal and is transmitted on the signal link. In FDM, bandwidth of a link should be greater than the combined bandwidth of the various channels. Also in FDM, each signal is having different frequencies. And next in FDM, channels are separated by the strips of unused bandwidth called guard band to prevent overlapping. So the function of the guard band to prevent the overlapping in the FDM technique. So there are the some features of the FDM. In this diagram, there are different inputs, signals or different input data, and these in the FDM system multiplexer convert into different channels, the channels 1, channel 2 and channel 3, and again the demultiplexer convert these different channels into different output signals or outputs data, that is the original signals. So this is the technique in the FDM systems. And what is the application of FDM? So there are many applications of FDM. FDM is used for FM and AM radio broadcasting, FM frequency modulation and AM amplitude modulation radio broadcasting. Next one application is the AM frequency use 530 to 1700 kilohertz. This is the AM frequency range. And what is the frequency for the FM? So FM frequency range is the 88 to 108 megahertz. So these are the frequency range of the AM and FM modulation systems. So FDM is used in television broadcasting. So FDM is used in TV broadcasting system. And next one application, first generation cellular telephone also use the FDM. What nowadays the cellular phones also use CDMA. But first generation cellular telephone use FDM technique. Now in the time domain, FDM technique. So in this diagram, there are different and input analog signals at the input of the have the different frequency which is F1, F2, and F3. So there are different inputs of different frequencies. That different inputs with the help of multiplexer multiplex and transmit to the a summation, and the output of this summation will be the FDM. So this is the time domain FDM technique. And in this multiplexer, the different input signals of different frequency applied to the different modulators, and the output of these different modulators have the different signals of different frequency F1, F2, and F3, and these signals again combined in the summation network, and the output of this summing network is the uh, sending bandwidth signals, that is the output signals. But in the demultiplexing in the time domain system, the FDM signal is also applied to the different filters, and the different filters output is again applied to the multiplexer networks, and these demultiplexer networks convert this FDM to the original signal or analog signal in the form of different frequency signals, which is the original signals. And in the multiplexing system, the received bandwidth signal is applied to the different filters which have the different frequency, and again the output of these filter is demodulated, and after the modulation the output of the different demodulators is the original signal or base signal. So this is the process in the demultiplexing systems, or the function of the multiplexer in that case. Now we discuss wave division multiplexing, or WDM multiplexing. So what is the WDM? WDM is an analog multiplexing techniques. Working is same as FDM. In WDM, different signals are optical or light signals that are transmitted through optical fiber, because the light signals or optical signals we can transmit it with the help of optical fiber cables. So various light waves from different sources are combined to form a composite light signals that is transmitted across the channels to the receivers. At the receiver side, this light signal is broken into different light waves by demultiplexer techniques. So this combining and the splitting of light wave is done by using a prism. Prism bends the beam of light based on the angle of incidence and the frequency of the light wave, and we can see in this diagram there is the wave division multiplexing WDM. With the help of a prism and the light signal which have the different wavelength lambda 1, lambda 2 and lambda 3 multiplex and converted into a single optical uh, signals which have the summation of different wavelengths, lambda 1 plus lambda 2 plus lambda 3, and these optical signal again convert into the original signal or original optical or light signal with the help of demultiplexing technique or by the demultiplexers. Next, what is the time division multiplexing, TDM? So in TDM, it is the digital multiplexing technique. So TDM is the digital multiplexing technique. Channels link is not divided on the basis of frequency, but on the basis of time. So in time division multiplexing or TDM, the channels is not divided on the basis of frequency, but on the basis of time. So in that case, the base is the time. Total time available in the channel is divided between several users. Each user is allotted a particular time interval called time slots or slice. In TDM, the data rate capacity of the transmission medium should be greater than the data rate required by sending of receiving devices. So in this TDM system, the different inputs are converted with the help of multiplexer into time slots. There is the different time slot 1, 2, 3, and 4. And these time slots again convert into the different input signal or original signal with the help of demultiplexing technique. So this is the uh, concept or function of the TDM process. What is the type of TDM? So there are two types of TDM. First one is the synchronous TDM and second one is the asynchronous TDM. What is the synchronous TDM? In synchronous TDM, each device is given same time slot to transmit the data over the link, whether the device has any data to transmit or not. Each device places its data onto the link when its time slot arrives. Each device is given the position of line turn by turn. If any device does not have data to send them, its time slot remains empty. So time slots are organized into frames and each frame consists of one or more time slots. So time slots are organized into frames and each frame consists of one or more time slots. If there are n sending devices, there will be n slots in frames in that synchronous TDM systems. So in this synchronous TDM system, there are different 5 inputs and these inputs converted into different 5 frames with the help of multiplexer. So in synchronous TDM, number of inputs are 5 and number of slots in each frame 5. So this is the synchronous TDM process. Next, multiplexing process in ST-TDM, synchronous TDM technique. In ST-TDM, every device is given opportunity to transmit a specific amount of data on the link. So each device gets its turn in fixed order and for fixed amount of time. Interleaving, that is the interleaving. Interleaving is done by a character or one byte. Each frame consists of 4 slots as there are 4 input devices. So slots of some devices go empty if they do not have any data to sending. So this is the multiplexing process in the STDM. In TDM multiplexing, there are different inputs, and these are converted into different time slots or frames. So this is the TDM multiplexing representation in this diagram. And again, the TDM process in the demultiplexing, and these time slot again convert into the different input signal or baseband signal or original signal with the help of demultiplexing process. So this is the process of TDM and demultiplexing. So next, what is the disadvantage of synchronous TDM? So in STDM, the channel capacity cannot be fully utilized. This is the disadvantage. The capacity cannot be fully utilized. Some of the slots go empty in certain frames. So this is the disadvantage of STDM system. There are framing bits. So there are different framing bits 0A, 1AD, 0A DC, and 1 DCBA, and 0 DCBA, and 1 DCBA. So these are in the pattern of synchronization will be 0, 1, 0, 1, and 0, 1. So this is the framing bits patterns in TDM. Next, what is the asynchronous TDM? So in asynchronous TDM, there are different inputs. These inputs are multiplexed with the help of multiplexer and convert into these number of inputs into number of slots in each frames. So there are different frames of slots. So asynchronous TDM, also known as statistical time division multiplexing. In this, time slots are not fixed or slots are flexible in asynchronous TDM. Total speed of the inputs lines can be greater than the capacity of the path. In ASTDM, we have n inputs lines and m slots, or it means m less than n. So slots are not predefined, rather slots are allocated to any of the device that has data to send. So this is the diagram of frame and address, which is represented different frames and different address in this graphs. This is the only 3 lines sending data. And here 4 lines sending data in the frame and address representation of asynchronous TDM. And also there are 5 lines sending data and represent in frames and addresses. Now we will discuss about the next topic, vestigial sideband BSB modulation technique. So what is the vestigial sideband modulation technique? So drawbacks of SSB single sideband generation is difficult to produce SSB signal from DSB double sideband signal. Ideal filters should be used. Selective filtering is to be used to reconstruct the original signal. Phase shift should be exactly 90°. In order to overcome these drawbacks, BSB modulation is used. So these drawbacks overcomes in SSB or DSB signals. So for due to the overcome these drawbacks, the BSB modulation is used. So it is a compromise between SSB and DSB SC modulation or double sideband suppressed carrier modulation. To produce SSB signal from DSB signal or produce single sideband signal from the double sideband signal, ideal filters should be used. What in BSB system, one sideband and a vestige of other sideband are transmitted together. So the resulting signals has a bandwidth greater than the bandwidth of the modulity or baseband signal, but less than the double sideband signal bandwidth. So this is the condition for the bandwidth. In BSB, transmission bandwidth equal to B plus B, where B is the vestigial or frequency band. So there are different spectrum of double sideband suppressed carrier and single sideband suppressed carrier and also vestigial sideband signals BSB. So first, so the original baseband signals, and second waveform show the double sideband system, and third one in the C is the single sideband suppress band, and last one in D is the BSB or vestigial sidebands. So there are different spectrums of different DSB, SC, SSB, and DSB in this different waveform diagrams. So what is the generation of BSB? So there are different methods for the generation of the vestigial sidebands. So first is the filter method. So this filter method is as shown in this diagram. So there is the a baseband signal MT, which is applied to the product modulator, and to the product modulator another signal, that is the carrier signal, which have the signal AC cos 2 pi FCT, that is the carrier signal, is also applied to the product modulator. In this product modulator, the two signal is multiplied, and after the multiplied, the output of this product modulator is the double sideband suppressed carrier, and this DSBSC signal applied to the sideband shaping filter, and after the sideband shaping filter, the DSB signal convert into the BSB waveform or vestigial sideband signal, that is the ST. So generation a DSB SC AM signal, pass the DSB SC AM signal through a band pass filter with frequency response HF. The exact design of the filter depend on the desired spectrum of the BSB modulated wave. The BSB filter required to have the vestigial symmetry around the FC, that is the carrier frequency FC. So the representation of BSB wave in time domain. So time domain representation of BSB wave is ST equal to S1 T cos 2 pi FCT minus SQT sin 2 pi FCT. So this is the time domain representation of the BSB wave in the mathematical form. Here S1T is the in phase component and SQT is the quadrature component of the ST or BSB signals. The in phase component may be derived from ST by first multiplying ST by cos 2 pi FCT and then passing the product through the low pass filter LPF. Similar, the quadrature phase components may be derived from ST by multiplying ST by sin 2 pi FCT and then passing the product through the low pass filter LPF. So S1F equal to S F minus FC plus S F plus FC, where F between the W less than or equal to and F greater than or equal to minus W. That is the for 0, elsewhere 0, and SQF equal to J into S F minus FC minus S F plus FC if F is the less than or equal to W or greater than or equal to minus W, otherwise 0. So spectrum of BSB signal is SF equal to 1 upon 2 AC MF minus FC plus MF plus FC HF, and also S1F equal to 1 upon 2 AC MF minus 2 FC plus MF HF minus FC minus plus 1 upon 2 AC MF plus MF plus 2 FC HF plus FC, and also simplified this, and S1F equal to will be 1 upon 2 AC MF and S1T or also will be 1 upon AC MT. And also the SQF equal to, after simplified, 1 upon 2 AC M1T. So thus the BSV modulated wave in time domain is S BSV T equal to 1 upon 2 AC MT cos 2 pi FCT minus 1 upon 2 ACM 1T sin 2 pi FCT. So this is the BSV modulated wave in the time domain. Or next, coherent detection of BSV system or BSV signal. So in this synchronous demodulation, there is BSV wave ST and also another wave cos 2 pi FCT, and these waves are multiplied in product network, and after the multiplier of these two signals, the low pass filter output is the MDT, that is the synchronous demodulated signals. So SF equal to 1 upon 2 in bracket M F minus MC plus M F plus FC multiply HF, where MF is the Fourier transform of the baseband signals. The output of the product modulator is SCT equal to ST cos 2 pi FCT, taking the Fourier transform of the both sides of this equation. So SCT equal to 1 upon 2 S F minus FC plus S F plus FC. So substituting for SF from first equation, so we get the equation 1 upon 4 MF into H F minus FC plus H F plus FC plus 1 upon 4 into M F minus 2 FC H F minus F plus M F plus 2 FC H F plus FC. So the spectrum of the signal S naught T at the output of the low pass filter will be S naught F equal to 1 upon 4 MF H F minus FC plus H F plus FC. So the for distortionless reproduction of the original baseband signal at the output of detector, it is necessary that transfer function of the filter must satisfy the following condition, that is the F, that is the H F minus FC plus H F plus FC equal to constant. So this is the constant. So this diagram of graphical diagram represents the magnitude response of the BSV filter between the amplitude versus different frequency, and there are different lower sideband and upper sideband in the form of frequency spectrums. There is an example of BSV signal in TV signals. So TV signals has a nominal bandwidth of 4.5 megahertz. This is the bandwidth frequency of the television system in the range of megahertz. If DSV modulation is used it requires 9 megahertz for each TV channels. What if VSB modulation is used? The whole TV signal is confined to about 6 megahertz. So we can see this frequency distribution of VSB signal in the TV systems. So there is the different frequency slots of picture carriers and receiver characteristics and remainder of lower sideband, and what is the frequency of video and what is the color burst frequency here, and also audio's frequency for the FM. So there is the some classification or some distribution of different frequency in the TV signals of the DSP signals. What is the advantage of DSP? So there are different advantage of DSP. First one is the DSP offer a compromise between SSB and DSP-SC, or single sideband and double sideband suppressed carrier signals. So BSB is standard of transmission of TV and similar signals. So BSB is generally used for transmission in television system. The bandwidth saving can be significant if modulating signals are of large bandwidth and in TV and wideband data signals. So for example, with TV, the television bandwidth of the modulating signal can extend up to 5.5 megahertz from 4.5 megahertz. With full AM, the bandwidth required is 11 megahertz in the TV bandwidth or TV systems. There are some multi-choice questions of this topics. The question is the very important and very interesting for clear the concept of these topics. So question first is the power spectral density of a signal is the option A even, negative and complex, option B odd, complex and positive, option C real, odd and negative, option D is real, even and no negative. So correct answer is the option D, the real, even and non-negative power spectrum density of the signal will be real, even and non-negative. So correct answer is here is the option D. Next, a modulator is a device used to option A. So what is the modulator used? So option A, differentiate two frequencies. Option B, amplify two frequency signals. Option C, impress the information onto radio frequency carrier. And option D, reduce the modulating power requirement. So correct answer here is option D. The function of the modulator as a reduce the modulating power requirements. Next, a balance modulator is used in the generation of which of the following signals? So balance modulator is used as a option A, frequency modulation signal, B, DSB SC signal, option C, ISI signal, option D, SSB SC signal. So correct answer here, the balance modulator is used in generation of double sideband suppressed carrier. So correct answer is here B. Next question, What are the primary feature of a transmitter? Option A, lower clock speeds. Option B, lower transmitting power. Option C, higher clock speed. Option D, none of these. So correct answer is option D. The feature of transmitter is a none of these. The next, the window gives a number of a byte. Option A. Option B, frames. Option C, both option A and B. Option C, D is none of these. So correct answer here is option C. The window gives a bytes and frames. Next, which of the given device does the data compression? Option A, switch. Option B, circuit breakers. Option C, microcontroller. And option D, source encoder. So correct answer is the source encoder, which give the device does the data compression. Next question, space loss occurs due to decrease in option A, phase shift. Option B, momentum. Option C, electric field strength. Option C, power. So correct answer here is electric field strength. Next, which of the given modulator is an indirect way of generating FM or frequency modulation? So option A, inductance effective modulator. Option B, Armstrong modulator. Option C, reactance tube modulator. Option D, Zener diode modulator. So correct answer is B, Armstrong modulator, which is indirect modulator for generating the frequency modulation. Next, in FM modulation, when the modulation index increase, the transmitted power, option A half, option B decrease, option C double, option D unchanged. So correct answer is option D, because the uh, index of the modulation is independent, not dependent on the transmitted power. And last question, in phase modulation, phase deviation is proportional to which of the following? Option A, the wavelength of the message signal. Option B, message signal. Option C, amplitude of the message signal. Option D, the phase shift to the message signal. So correct answer here is the message signal. So these are the some multi-choice questions. So thank you very much.